Hey guys, welcome to our third video for Unit 5. Actually, fourth video because the first skill had 2 videos. So I'm very excited to introduce you guys to logarithms. It's really one of my favorite topics, okay? So in the box it says, when you have log, this is called base, log base A equals x. So when you have log base A equals x, make sure you read it correctly, okay? This is read log base log base B, base B of A equals, equals x. So this is read log base B of A equals x. You can only write it in log form if the original exponential is b to the x equals a. So when you write it in log form, you have to look at your exponential. You can always go from exponential to log and log to exponential. These two are equivalent, okay? It's kind of like saying, okay, well, you were in your pajamas last night and then you're putting on your day clothes. It's still the same exact equation and same values, except that you are looking a little bit different, but it's still you. So same thing with this. B to the x equals a. It's equivalent to log base B of a equals x. So the base will always maintain under par or subpar, okay? And it's log subpar base, and your answer goes here, and your exponents is here. So what that means is b to what power equals a, okay? So b to what power equals a. So that's what we're trying to see. So examples 1, 2, 3 are just rewriting it in log form. That means it's an equivalency of the exponential, okay? This is to get you guys comfortable about going forward, which is to log form, and going backward to exponential. So as you can see, your base is 5. So you want to write. Now I want you to be very careful. I want you to write 5 subscripts of log. So you should never, ever have it like this, log 5. That would be completely wrong, okay, because that's not a base. So now log base 5 is now a subscript of 125. So now, and then equals your exponent, which is 3. So as you can see, what's on the same line should be 125, 3, and log. 5 should always be below all of those things because 5 is a base. And that's it. That's how we write exponential to log. Now, I would totally give you the wrong, I would not give you any credit if you'd write it like this. Okay? That would be completely wrong because 5 is not on the same line as log. 5 is a base, so be careful. And then let's do the same thing for example 2. Your base is 49, so that's log base 49, okay, of the answer, which is 7, equals to your exponent, which is 1/2. And last one, log base, what's your base? Base is 2 of what? Of 64 equals to 6. So as you can see, when you're writing these, the base should always be below all of the other numbers. Now, I want you to think about log for a second because I want to show you what log is. Let me go to my calculator. Nope, that's not what I want. Let's go to, here we go. So log, let's talk about the first one, log 125. What is log 125? Log 125 is just a number. It's an irrational number. It's an ugly irrational number that keeps on going out. The decimal doesn't ever change. Now, what if we do log of 1? Well, log of 1 is 0. Well, what if we do log of, oops, shouldn't have done that. I meant to go down. Okay, so what did we do log of 0? What? Log of 0 is undefined? Can log be negative? Let's check it out. So if I punch in log of -6, nothing. So you can see log can't be 0 or negative numbers. Now, earlier in our example, I want to type this in. See this right here? I want to type that in to see if it equals 3. Okay, so log base 5 of 125. So let's, oh, why did I do that again? Let's go here, functions, miscellaneous, log base. Okay, so log base 5 over, can you see that when you write log base 5, there's no answer? Log has to have a number after it, so make sure you don't write just log by itself. So look, log base 5 of 125 is 3. Well, what if you check the other ones? What if you check this? Log base 49 of 7. Is it going to give us 1/2? Well, we don't know. Let's try it again. Log base 49. So let's type in 49 over, oops, what did I do? Oh, of 1/2, so 0.5 of 7, sorry, just see if it equals a 0.5. There you go. What it is, it's the same. So as you can see, it's an equivalent equation for exponential, okay? Because sometimes it's easier to use log, as you can see later, to solve, and sometimes easier to use exponential. Not all of the time that you can solve in exponential form, and not all the time you can solve in log form. So you need to be able to go forward and backward. So at some point, it's easier to use one or the other. All right, let's go to the next set of examples. Ready? Oh, here we go. Okay, so now that we are comfortable with writing exponential in log, we are now going log to exponential. So your base is 9, so base is 9, so you want to start at 9. So 9 to the answer equals 81, okay? 9 to the answer equals 81. So 9 squared equals 81, which is always true. This one, your base is x, x to the answer, which is third, equals 343. Box that up. We're just writing into an exponential form, and then box that up. Now it says solve for x if possible. Well, can I solve for x? Sure, why not? Why can't I take the third root? So now x to the third, we want to do is take the third root to both sides, 343. So now that we're taking the third root, as you can see, x to the third is an inverse of cube root. What's third root of 343? Let's see. Okay, it gave us a nice number, so x comes out to be 343 is 7 times 7 times 7, so the answer should be 7. So 7 to the third equals 343. Okay, next. So that number 5 has 2 answers. Make sure you box both. First thing is write in exponential form. We are going to start with a base of 6 to the -4 equals 1 over 1,296. This one, there's no variable, so we do not need to solve. And that's it for going from log to exponential. 7 to 10, I believe these are the last 4 questions. These are sets evaluate, meaning that you have to find the answer without using your calculator, okay? Let's try. So log base 3 of 81, log base 3 of 81. We wanted to say that, okay, let's pretend that it equals to some answer. We don't know what that answer is. Right now, we can't solve it in log form, but what if we rewrite it in exponential? 3 to the what equals 81. We know how to solve exponential form already. We have to make the bases the same. So 3 to the what? 81 is 9 times 9, and 9 times 9 is 3 times 3, and I got 4 3s. So now 3 to the what equals 3 to the 4th? Well, bases are the same. I'm looking for that blank box, so that blank box has to equal to 4. So the final answer is 4. Similarly to number 8. We want to say, okay, well, what is my answer? We don't know right now, so give it a box. We can fill that in later. Rewrite it in exponential form. 2 to the what? Equals to 1 over 32. Well, 1 over 32, we can rewrite it as a negative exponent, of 1. Well, we know, 2, it's already a prime number, so we do not need to rewrite the 2 as our base. Why do I write 2 boxes twice? 2 to the boxes equals, well, 32, as you know already, well, 32 is 2 to the what? 2 to the 5th, you're right. And then raised to the negative 1 power. I'm going to move it to the right. So that's 2 to the box equals power to the power. You would multiply those, so that's 2 to the negative 5. Well, guess what? The bases are the same now, so this box equals to negative 5. So negative 5 is our answer for number 8. Now, what if you don't feel like writing as a box? You can use a variable x. It doesn't really matter. I'm just using a box for the sake of simplicity, okay? So for the next one, we'll use x. Okay, that's what, okay. So log base 7 of 7 to the 3rd power equals some answer called x. Well, again, same thing. We do not know what the answer is without a calculator. So we are going to try to write this in exponential form. Your base is 7. 7 to the answer, which is x, so this x is really now here, equals 7 to the 3rd. Oops, where's my 7 go? Okay, there you go. 7 to the 3rd. Okay, whoa, wow, what? Bases are the same straight up? Perfect. So guess what? This answer comes out to be 3 right away. But here's what's more important for this question is, I want you to have an understanding of this. Log base 7 of 7, it's always going to give us a 1, okay? Again, log base 7 of 7, or log base 2 of 2, it's always 1. Or log base 10 of 10 is always 1. And 1 times 3, that's why we have 3. So log base, any base number, whatever base you want, of the same number will always equal to 1. If you understand that, it will be a lot easier for us to solve later. I want you to remember that. Again, memorize on that, so later it's going to help us out, okay? Next, last one for this video. This one says 4 is raised to the power of log base 4 of 11. Oh man, that seems so scary, right? Right now, it's an exponent, but your exponents, it's a log. So we don't know what the answer is, so let's give it an x, because we use 2 questions that we use boxes, and now let's just try to solve it normally like x. Well, I can't solve it in exponential, because right now that is an exponential, so I will rewrite it as log. Your base is 4, so I'm going to write log base 4, okay, log base 4 over my answer, which is x, equals the exponent, which is log base 4 over 11. Notice whenever I'm saying the word base, they should all be a subscript, okay? So please do not write the 4 along the line of log. Well, what? Now we can solve for x. But here's the thing, guys. Both sides have the word log. Both sides have log base 4. Just like earlier when we had the same common base, we can drop them. That's the same thing here. We can drop these because they are identical log and identical base. So x comes out to be 11. Yes. Okay. Now, but the bigger takeaway from this is really this piece. 4 to the log base 4. Okay, I'm going to get a different color. 4 to the power of log base 4 of anything here. Okay. Well, we do not know what that anything here in that blank space. So I'm going to highlight that blank space. So 4 to the log base 4, just this piece alone, will equal to 1. Okay. But 1 times 11, that's why we have 11. Okay, so because the base is, the green box was 11, so that's why that's 11. So what if you have 10 to the log base 10 of something here? Then this will always be 1, and 1 times to, let's say, what's the number? W. So 1 times W, so this would be W. So guys, this will always going to be 1, okay? Oops, 1. Why am I writing 11? 1. So also understand that. That's a bigger understanding than that. So another thing I want you to understand is base, okay, to the power of log of the same base. So there's a base, this is an exponent here, of something, because this is always going to be 1. Then whatever the answer is here, that's what it is, okay? So that will always be 1. So if that equals green. So if you understand that, memorize that, that will help you out later. All right, this is the last of our video.